Graphing rational functions, section 2, finding holes. So this is the follow-up to the previous lesson of establishing and finding the domain of a rational function and vertical asymptotes. So this is really the next step to that, and we saw something that kind of led into this when we saw the lecture on vertical asymptotes, that occasionally, well, the first step is to factor the numerator and denominator, and occasionally what we'll see is that they have a common factor that crosses out. And that common factor that crosses out, that is still a restriction on the domain. If but it's not a vertical asymptote. And in fact, what it is it's a hole. And so that's where this kind of comes in. So we'll see that here. Now, our first slide is what we already had in our notes. If you were properly taking down your notes last time, you should have steps 1 through 5 in the procedure: a factor numerator and denominator, cross out any common factors, and this is kind of where we're coming in today. That's what's going to lead to a hole. Set the denominator not equal to 0. That finds your vertical asymptotes, and you can write your domain and interval notation, and we'll review a little bit of that today again. But we're focusing on adding a number 6. So if you go to your notes, you can either rewrite this as a whole new thing, or you could go back and add to what you had before. And step number 6 here is find any holes. And that's really what we're discussing in this lecture. Now we're going to be adding 7, 8, 9, 10 to this as we go on throughout this chapter. So finding holes, and as I mentioned, this really comes from this, crossing out common factors. So let's talk about that. Now the first couple of examples, I'm just going to focus on the part about finding holes. In the last lecture, we were finding the domain, we were doing vertical asymptotes, stuff like that, and you still need to do that in the overall process. Like when in a couple of lectures from now, when we get to graph this, we're going to go through all these steps. We're going to find, all these various things. But right now, I just want to focus on finding the holes. And so first thing is we do still need to factor the numerator and denominator. That's the first step no matter what. We see the numerator here is a very simple, very common, very basic difference of two squares or dots, factors to x plus 3, x minus 3. Remember, for this chapter, the factoring is really nothing too advanced. You could definitely use your calculator and trace out roots and stuff like that if you need to, but the factoring should be something you should be able to handle. The bottom is a very basic trinomial, no AC or completing square needed, very just basic, what multiplies to this, what adds to this kind of thing. And so the factors of this trinomial are x plus 5 and x minus 3. And notice that they have a common factor of x minus 3 that crosses out. Now this x plus 5, we would set it not equal to 0, and that would give us an asymptote. We'd end up with an asymptote at negative 5. But the x minus 3 that crossed out, it's involved in the domain. It's a restriction for the domain. We can't have that, but it's not an asymptote. This is where the holes come in. So the value that crosses out, this x minus 3, you solve it the same way you would if it were an asymptote. And so you end up that x cannot equal 3. But what this is it's a hole. It's not a vertical asymptote. Now a hole is like if you picture a graph and you have this function on a graph, it's a little bit different than a vertical asymptote in the fact that it's actually like a hole in the graph. There's a spot where there's just a gap. It's not an asymptote per se, where there's this whole line that the graph approaches but never gets to. There's just this hole in the middle of the graph. And so it's actually a coordinate. A hole is a coordinate. It's an x comma y coordinate. And what we just found is we found the x value of the hole. And we need to now find the y value. The way to find the y value from the hole is after you factor the numerator and denominator, if we go back to our steps, factor numerator and denominator, step 2 is write in lowest terms. And what that means is you want to rewrite this without the x minus 3's. So the function would become x plus 3 over x plus 5. And so that's our new function. The way to find the y value of the hole, let me get rid of that. I'm meant to put a y there. The way to find the y value of your hole is you're going to substitute this value of 3 into your new reduced function. So if we place 3 into this function, we end up with 3 plus 3. What I'm doing is I'm replacing x with the x value of the whole, and 3 plus 5. 3 plus 3 is 6. 3 plus 5 is 8. We can reduce it, dividing everything by 2, to 3 over 4. And this is the y value of the whole. So we'll look at a couple more quick examples, but that's essentially it. That when you factor the numerator and denominator, and that's how we always start all these problems, if you see a common factor that crosses out, that's not going to give you an asymptote. Instead, it's going to give you a whole. And the way to do it is you solve for x just like you do the asymptotes, but it's not a vertical asymptote. Instead, what you just found is the x value of your whole. And you then plug that number into the reduced version, you know, what doesn't cross out, and that'll give you the y value of the whole. So let's look at another example. And we talked about this in class, and I've mentioned it many times in the video, but I suggest maybe pausing the video and writing this problem down, and then, you know, unpausing it so you're ready to go. So I'm assuming now you've unpaused and you're ready to go. Okay, so let's factor the numerator. It factors to x plus 5 and x plus 1. The denominator factors to x plus 5 and x minus 2. We have a common factor of x plus 5. The x minus 2 will end up giving us a vertical asymptote that x cannot equal 2. But let's just focus on the whole aspect of it. So this is going to give us a whole because it's a common factor of the top and the bottom. And we can end up getting x does not equal negative 5. What would make that particular factor 0? Well, you could always set it not equal to 0 and solve and so on. But what we just found is we found the x value of the whole is negative 5. To find its y value, we need to substitute into what's left of our rational function over here. So what's left is an x plus 1 over an x minus 2. If we then substitute these values with our negative 5, that's negative 5 plus 1, and negative 5 minus 2 is going to give you negative 4 over negative 7. The negatives will cross out, and we end up with 4, 7 as the y value of the whole. All right, one more problem I want to go over, and what I'd like to do is I'd like to do this problem with everything we've discussed so far. I want to do the domain, I want to find the vertical asymptotes, and let's see if there's also a whole involved, and I have a strong suspicion there will be because that's kind of what this lecture is about right now. So, factor the numerator. Factors to x, and that leaves you with x squared minus 4, which then factors to x, x plus 2, and x minus 2. The bottom is a simple GCF. Take out a 6, get x plus 2. And right away, I see I have a common factor of this x plus 2 that crosses out. Now, it crosses out, so it's not a vertical asymptote, but it is going to instead be a whole. So we will have a whole, and the x value of that whole is going to be negative 2. It'd be what would make this 0, right? And the y value of it is replacing negative 2 into our new function over here. So once these x plus 2's are crossed out, writing this in lowest term gives us x minus 2. Hold on, I just want to clean that up a little bit. X parentheses x minus 2 over 6. And so plugging a negative 2 into that is going to give you negative 2 parentheses negative 2 minus 2 over 6. Negative 2 minus 2 is really negative 4, so you're looking at negative 2 times negative 4 over 6 equals positive 8 over 6, finally reducing to 4 over 3. And so that is the y value of the whole, 4 over 3. Now I said I wanted to do this problem start to finish, so are there any vertical asymptotes? Well, there are no x terms, or there's nothing like this that didn't get crossed out. See, in the previous example, this x minus 2 that didn't get crossed out, that would give you a vertical asymptote at x cannot equal 2. But in this example, there's nothing left other than this 6, so we actually have no vertical asymptote, so we would just write none for vertical asymptote. And finally, let's state the domain. The domain is all the values of x starting from negative infinity, and the only restriction we have is the x value of the whole. So that'll go to negative 2, and then we'll also have a domain go from negative 2 all the way to positive infinity. And if we had a vertical asymptote, that would also be factored into our domain, but there's not one in this example, so we don't need to worry about it. So that's it. That's how you can now incorporate finding holes into preparing to graph your rational functions.